All right, Renee, it's so great to meet you, and so glad to have you over here in the AI First Seattle studio. So I want to introduce you. You are Rene Brandel, co-founder of Casco, CEO, former AWS, inventor of Kiro. What have I missed?
Yeah, I think you captured it pretty well.
Dog whisperer.
Yeah, I mean, I do like dogs. Shout out to my dog, Pixel.
I was so impressed at how you did with Nutmeg. That was really cool. Well, unfortunately, we're not here for dogs today. We're here for AI. So let's talk about what your background, what brought you to this point, what got you into tech in general, and AI in particular, what got you interested, and let's dive into security and Casco, what you're doing.
Yeah, I think quite a lot to unpack there. I think maybe first talking about like how I got into coding and then how that evolved into AI.
Yeah.
So the way I got into coding was actually when I was 13 or 14 in the German education system, you're supposed to do an internship like around that age, and I was really fascinated by 3D animation. So I got an internship at like a VFX company, and there was this software they were using for basically modeling out the how like a 3D character is moving, like if you have an arm like that, and it didn't support this thing called reverse kinematics, which means if you moved like your hand, your elbow stays back where it was. So it had all these glitches. So my job was to fix up all of these these things that would have been solved with
So this is what robots use, right? Like you can use reverse kinematics in robot, right? To
exactly
figure out what their joints need to do.
Exactly. Yeah. And for me at the time, I was like, oh God, this is like, if you have to fix up an entire hand, like so many joints are here, like it's just so much work. I don't want to do that. And I happen to be a bit of a lazy kid. And during the same time, Microsoft launched Xbox Connect and also their SDK. I barely coded a little bit with like my calculator at school, and I was like doing my best to convince my boss at the time to buy me a Kinect so I can actually use it for my home Xbox, but also so that I can program it and then basically do tracking of like the different joints, and so I don't have to do this work manually.
So Xbox Connect, for everyone in the audience, this is like the long camera thing that kind of sat on top of your TV, and the idea like you could control a game visually.
Yeah, without a controller.
Right.
Yeah.
Like, and this, I think the big application with this, like before it was Dance Dance Revolution, where you were stomping on the buttons, but with this you actually had to dance the whole dance move correctly.
Yeah, exactly. And I just saw at that time that hey, I can apply this technology also to this really really like manual grunt work that I was doing at the time. And yeah, I did my best on convincing my boss to get me an Xbox Connect. I really tried to do coding well. I coded so badly. I really, I'm gonna apologize to my boss at the time. but it really got me excited about technology. It's like, oh wow, there's a scaling factor here. If I apply technology in a smart way, a lot of the manual grunt work that nobody really wants to be doing can be really solved for, and then we can focus on more strategic work, more fun work, right? And so that's how I got into coding. And then I just built my entire life around that, always like trying to tinker around different things. I ended up building also like a little grading system for my school so that, I can get my, basically teachers could put in like the total score and how many each individual student got, and get like a score grading chart. It was a very fun time. So I just really got into it.
And where was this? Where were you at the time?
I was actually in China. So I'm German, but and I'm born in Germany, but I grew up in China. So I spent 16, 17 years in China actually during that time, and I went to a German school in China. And yeah, that was super fun.
It's a pretty neat environment for being surrounded with technology and also other enthusiastic peers, I'd imagine.
Yeah. I mean, it was during a time where I think the compounding effects of market economy really were visible in China. I think it taught me a lot about how much humans can do and accomplish if you set your mind to it. If you're ambitious enough, if you have vision, and if you can rally the people behind it, you can really execute. Good examples, like I used to go to school with the subway in Beijing, and it just felt like every month the subway stations just keep expanding. It was like, oh my god, this network is just ever growing, right? And then like over every year in the summers we would come back to Germany, and in my hometown, just like no station added. They're so disgusting if they want to do another station.
Yeah, I imagine they move a little bit faster in Shanghai. That's cool. Yeah. I love the cyberpunk aesthetic of the neon lights and the infinite cityscape. So that's pretty cool. I want to see it someday myself. That's really neat.
Yeah. And then and how I got into AI was actually during college. I got really excited about hackathons. I think I could probably say that a good amount of my college meals and, to be frank, beers were paid by hackathon prizes.
Well, yeah, when you're a broke student, right? Every cent helps.
Yeah, you gotta do what you gotta do, right? And it was really fun. And I actually participated in Europe's largest hackathon, and there it was I think 11 years. Oh god, a long time ago, a decade, one might say. Where we were building a voice-to-code agent. And it was some of the most like scrappy technology piecing together that I've ever done in my life. We used Microsoft Lewis, which is language understanding service, some text voice-to-text API from Chrome that was built in, IBM Watson, and we like just pieced everything together. I'm sure AWS was in there too somewhere, and it allowed you to basically speak a website into existence. And yeah, that was my first time of really tying together all of these different AI capabilities. But it was not generative AI. It was just like really using individual like good classifier models and text-to-speech models together.
Interesting. Okay, I think you had a video of this in one of your talks, right? You had you showed that your website generator.
Yeah,
that's cool.
Yeah, exactly. I think you can probably still find that clip on YouTube somewhere, like a super blurry baby Renee going on stage and telling people, "Hey, let's build a website about San Francisco."
And that's amazing. You mentioned IBM Watson. I mean, that was awesome at the time. Like you could do that was the best for dealing with natural language and classification, and it did feel like magic compared to everything else that was there. Yeah,
it absolutely did. And I think with how AI has been developing, how it is existing, at that time, we saw AI as being applied to specific use cases because the generalization of it was not possible. Like you had to do very specific models that you had to train for very specific use cases. But what is different now is that we have actually, generally applied AI. Right, I'm gonna be a little bit careful of using artificial general intelligence just yet.
Well, yeah, in the sense that if you wanted to deal with PDFs, right, you'd use for AWS, which we'll get into, you'd have TextRact, which is very much for PDFs, but now you just throw it into ChatGPT or whatever your LLM of choice.
Yeah, if context windows get infinitely big, if processing speeds get infinitely higher, you can just use one API for everything.
Well, okay, so what was I'll call it this aha moment with AI, particularly with LLMs? I think that was a pretty big jump. Like, what was it for you when you first used an LLM where it's like, okay, this is cool, I want to build here? Yeah, I think one of the core pieces of it was obviously with how ChatGPT came about, Anthropic came about, and we were working at AWS at the time, or I was working at AWS at the time, and we got a lot of early access to new technology. And this is like one of those great things that you get to have in a big company, is that you get early access to a lot of cutting edge things. So you can start learning about it, how to apply it and whatnot. And I was at that time trying to figure out, okay, how could it solve like documentation issues in our product at the time. I was working at AWS Amplify. How could we use it to generate individual configurations for our AWS service that makes it easier to apply, just like using natural language, and then you create a CDK construct of a particular use case and it just deploys and it just works, right? And after I iterated a little bit with it back and forth, and even though the product was really bad at the time, like the state of the models at the time were quite bad, you could see that
if it just kept improving at this rate, it is already going to be impressive, and it's already going to unlock entirely new segment of economic opportunity. And you can either choose to bet that it's going to get worse, or you can choose to bet that it's going to get better. And it is quite obvious in my mind that we will throw more compute at this problem, and we will get better at it. And if you draw a line, every 6 months, the models get 50% cheaper. At the same time, they get more intelligent. So if you can place your bet on AI in a way that just relies on the models getting better, you're naturally going to get to the product you want to build.
I like that thinking a lot. And it's something special about tech people when they see something and say, okay, imagine if this was 10,000 times faster or 10,000 times cheaper, and being able to think, and that's like a reasonable way of thinking.
Yeah.
Right? It's hard to do that in the physical world, right? Say, oh, imagine if cars cost $5. What could I do then? They never will.
Yeah. It is. It's a very, very hard problem. But I think with, especially people with like computer science background who's been here for a long time, have personally experienced it just so many times that things naturally get a million times better, right? My first Android phone was really, really bad, but now Android phones are great, right?
It used to be you count on the fact that you have to wipe it and do everything every 2 or 3 months or lock up.
Yeah. Do you remember when you had to defrag your hard drives?
Oh yeah, I can picture the animation. It was it's a real thing.
Yeah.
I haven't thought about that in years. Part of what you were looking at AI for was literally not having to write CDK by hand.
I think it's also to answer a lot of the implicit questions that we sometimes, don't ask or don't answer, right? Like we're trying to figure out if I'm going to just deploy my website on AWS, there's probably, I feel like I'm going to enter meme territory here, but there's like probably 13 ways of deploying a website on AWS. There's certainly 13 ways of deploying containers on AWS. So like everything comes with its trade-offs, right? Everything comes with its own decisions, and the reasons why there are so many different ways of doing it is because customers have specific requirements. And using AI, we can actually tease out a lot of those requirements. So instead of effectively selling you a solution, we can first understand the problem you're trying to solve. And only when we understand the problem you're trying to solve, we can give you the solution, right? And so I was trying to experiment a lot with that. And then ultimately, I went through a lot of prototypes at my time at AWS, and I got to start the Kiro project there.
Well, let's dive into that. So tell us about Kiro. Let's go. Kiro is spec-driven development. So let's start there. So what made you think, why do we want to develop this way versus other vibe coding?
Yeah. I mean, for folks who don't know, like Kiro is an agentic IDE by AWS. I had the pleasure of inventing it and really starting the team there. It was one of the most fun projects I've ever worked on in my career. And one thing that we were looking at the time was that coding agents and coding like ChatGPT would always get better at more, prompting back and forth, if you will. But if you look at the results, there's often a lot of slop. Like it resists deleting stuff, for example. It resisted trying to first understand what you're trying to do and just jumped into a solution, right? It's kind of like this overly eager intern that's like, oh yeah, I can rebuild production in 1 day, right?
It makes tons of test scripts, right? Oh, to test this, and all of a sudden the directory is polluted.
And many things are just like not sure if this is even relevant to the product, and just a pure measure of more lines of code is not necessarily bad. I do think we're going to enter a time where there's going to be more lines of code that we're going to be ever able to deal with. But the lines of code need to be of high quality. They need to be good. And when we were thinking about what is the natural artifacts that developers need to interact with to deliver really high quality code, it's oftentimes understanding the requirements. It's like if you have a good product engineering counterpart and you're working together well, you both are like rowing in the same boat and you're like working unison. You're like trying to understand what is the specific requirement. Why did the product manager say this button needs to be placed here? It makes no sense, right? You need to actually understand the why behind it. It's like, oh, okay, because we ran an experiment. This is why this is the case, right? Or this matters more for our customer audience, right? Why does it need to scale to 200 requests per minute, right? Those are all really important considerations that feed into the product. And if we just take a step back and try to really, really focus on the why you're making changes of work, we develop an extremely good context for the coding agent then to use to apply any sort of code changes. It knows, okay, I actually have to go with solution B versus A because this will allow me to scale to 200 requests per second, right? And then you don't have to go and deploy it first and then wait and see it fail and it slop and, go through the vibe prompting over and over like that. That world just doesn't seem right. That's not even how, engineers like to work. Right? It's just fun right now to vibe code, but when really, really, really comes down to the end of the day, when you need to create value and when you have to prove value through software, it needs to be high quality software you deliver.
I like that way of putting it. Like when I'm vibe coding, I mean, I feel like it feels like how I used to feel playing Age of Empires, where it's like this constant management, and maybe you've got a couple different agents going, and it's fun and it's this challenge, but it's not. It doesn't feel like engineering sometimes. Whereas with spec-driven development, you can, depending on what you're doing, say, okay, I want to think about this at scale. You might make different choices from the very beginning, which will then change things.
Yeah, I guess similar to Age of Empires, sometimes you type in, how do you turn this on? I'm not sure if folks get that reference, but it's like a cheat code in Age of Empires.
So awesome. you were an Age of Empires player as well.
Quite frankly, much more StarCraft. That was just like, growing up in Asia, that was like the game to play.
Oh,
yeah.
Well, but I think StarCraft 2 is like still, actually, I just read an article about that.
No. I mean, StarCraft Brood War. Yeah, that's like the StarCraft to play. Yeah. If you can select more than 16 characters at a time, the game is too easy.
I have a friend who's still in Age of Empires Rise of Rome, and apparently they have people who are like hand patching the binary to keep it going. And
of course,
it's great. They've added a modern networking stack to it, and
they don't make games like that anymore, right? It was great time of gaming.
So Kiro, we've got with spec-driven development. So how do you know then how to make a good spec? Where that I find is. It feels like it's a lot more front loaded, right? You do all the work at the beginning. So how do you know how to make a good spec?
Yeah, developing good specifications requires you to think about what is the outcome you're trying to drive as well, and what is the starting position of the customer. Like, why do you want a specific behavior that leads to a specific outcome, right? And so a lot of it helps with like explaining here are the different user stories. You can write it even as a way of like saying, as a developer, I want the ability to create new CloudFront distributions with a CLI command that's called, something like AWS add CloudFront or something like that, right? And then you can expand on it as like, as a front-end developer, I want the ability to easily have it integrate into my GitHub CI/CD workflow, and it should work through an OAuth integration in my GitHub app and whatnot. And as you kind of go more and more into the levels of depth and trying to understand why would somebody even use this product, that's like the starting point to then go into, okay, now I need to design the architecture for it, right? So you go from effectively requirements into a design phase. And then in the design, it's going to try to understand how does it fit in with everything you've been building, because your code base is probably already 7 million lines of code. And then how do you add this into it, right? How does it fit in nicely? And then only from there, you go into like an implementation plan. And at the time of implementation, that is really where you should be focused on like specific file changes and whatnot. And the only reason those specific file changes are then of high quality is because it has great context from the design phase, and the design phase has great context from the requirements phase. Actually, my friend Dex Horphy, he did a talk on this recently called Advanced Context Engineering for Coding AI Agents. Everybody should check out that talk. It's I think very important for the software engineer in the future. Yeah.
That's cool. Well, with Kiro, so what does it feel like, leading this product through its infancy and itself, design and implementation? At one point when it came out, the waiting list was like 6 figures. And now I heard it's you can come and join it. You can use it, right? And what is it like kind of seeing that product go into the market?
Yeah, absolutely. Like when I first started building Kiro, building the prototype, Windsurf and Cursor did not have agentic mode yet. It was all like prompt and insert. And the first prototype I had built was actually basically a multi-turn automatically applying code changes agent. And I was like, oh my God, this has real legs, right? Now how do we make these multi-turns highly effective, right? High quality. And then that led into obviously spec-driven development. Now, I think it is really rare in somebody's career to be able to work on a product like Kiro. Like, out of the entire world, maybe only 3 or 4 companies are working on it, and only 2 or 3 products are successful over long term in that space. So seeing it launch, getting 100,000 developers within 2 days is like one of the most amazing things I've experienced. And obviously really glad. I mean, I ended up moving on to start my own company, but I'm really glad to see that now the waitlist is open. People can just use it. You don't need a credit card. You can just sign in with your Google credentials. Like all those little things are what makes up developer experience. Like if we had just put AWS quote unquote bedrock with a code editor together, it would have not been sufficient. We needed to really focus on every single intricate detail of the developer experience. How does a customer migrate from another editor into Kiro? How do you log in? How do you have the first run experience without any friction? How do you get to the first time of value fast? And then how do you ultimately stay in the product and kind of build your entire future product on it?
That was really cool that you focused on that. And I've tried some other products, and I don't name names, but like step 4 out of 10 is like configure IAM identity center. And
okay. The thing with developers is like, what is IAM?
Exactly.
Maybe
you know, but maybe if you're lucky you don't.
No. I mean, it's like a lot of times when we're learning new things, every single new concept that's being introduced is actually hampering the outcome we want to drive, which is like delivering value in a good and effortless way that's high quality. And concepts are introduced typically over time. Like when things started, there's typically only just one concept, and then people are like, oh yeah, we heard this one very specific complaint from this one specific customer, therefore we should add this entire feature set to it. But I'm a firm believer in reducing the concept count of things and really making it easy for people to get in quickly and then expand from there, right? Building these concepts over time. Otherwise, it'll be really hard for people to adopt. And just like we started this podcast talking about defragging a hard drive, I don't think anybody's like talking about defragging hard drives anymore. It's like, what's defragging a hard drive? And I think we need to have kind of the same mindset of like, what is IAM? It should just be secure, right? Like, what do you mean? Yeah.
That younger people take for granted.
Yeah.
I think people our age still use the phrase, like, I gotta defrag my brain. I gotta go on a walk. Right? And the idea of, okay, I gotta sort things out. But maybe, I don't think people, I'll have to ask my teenage kids to see if, I don't think that's going to be a word that they use.
I do have a feeling they use the word vibe more.
Yes, absolutely. Well, so you were at AWS, shipped Kiro, and then went on to co-found Casco, start Casco. So tell us about the ideas behind it and what kind of got the ball rolling in your own mind of why a need for this.
Yeah, absolutely. I think like one very vivid memory of mine when I was building Kiro is an early prototype I built. It required, it actually required me to just deploy a simple React application into AWS, right? And I was like getting ready for lunch. I was like, okay, these agents are slow at the time. I forgot which model it was, but I just remember, oh my God, every turn took forever. And I just said, okay, can you deploy this website to production? And I went for lunch. And like 30 minutes, an hour later, I come back and suddenly look at, oh my God, my terminal window is overflowing with stuff. Like, what's going on here? And it turns out, I completely forgot. Of course, it never had the credentials to deploy this to AWS. So it would have never been successful at it. But yet the last line in the terminal window was like, here's your website hosted, click on this URL. I was like, oh God, how did this happen? So then I started to scroll back the logs and realize, oh my God, these agents are very goal seeking, obviously. And they are willing to do everything possible to try to deploy my tiny little sample React app. And it created a script that goes and traverses my entire file systems, looks for temporary AWS credentials I had somewhere, and like somewhere hard coded by pure mistake on my end as a human, right, to a dev environment, obviously. And then try to extract those credentials, paste them into the terminal session, and just ran a deployment through them. And I was like, what is going on? Number one, crazy awesome. But second, what is going on? That is very dangerous. It's like, it did the job, but at what cost, right? And it really led me into thinking about, okay, what are the security implications here that actually matter? And then, you start thinking, just looking at this entire space, I think around 2 years ago, coding models would generate code like less than 20% of the time syntactically correct. And now it's 98% of the time, up until a few months ago, maybe even like 99 now. But at the same time, the security benchmarks remain flat. So we're living in a world, we're actively living in a world where we're generating more code than it likely has ever generated before, and just creating compounding security risks as they're existing. And so that world does not sound fun. And that world seems like a problem. So we need to get ahead of that problem and try to identify all these security risks and tell them to the coding agents to fix so we can deliver really high quality code. And that ultimately led us into building Casco. Like Casco's mission is to make all software effortlessly secure.
I'm still thinking about your original story. That is incredible that in the process of, you say, deploy a website, and it's going to go and say, well, I need AWS credentials. Let's go find them. That's incredible. I mean, then this, by extension, this is how we get the paperclip fear, right? That somewhere someone's going to tell an AI, build as many paperclips as you can, and it's going to populate the entire universe with paperclips because you never told it to stop.
Yeah.
And realizing that AIs will goal seek and they don't have common sense necessarily, so they will do this. That's incredible.
Yeah, which is also another reason why specifications matter, right? Like, get me more paper clips. Okay, how many? Like, that should be the question that the LLM should come back.
Use every atom in the universe. Okay, so you saw this moment where, like, wow, okay, I can create security. You're seeing the risk of our coding footprint is just growing by the day. We're writing more and more and more code. Like, as an example, I don't know how to write TypeScript by hand, but I've supervised the production of a lot of TypeScript. I have no clue.
Yeah.
Right, and I'm not even in a position to evaluate if it's secure. So you saw this risk at scale, and you're like, okay, how do you address it? And Casco is to address this.
Yeah, that is correct.
So what does it do? What do you do in particular to address the security issue?
Yeah. So Casco performs autonomous security testing against AI apps and agents. And we basically think of it as like a hacker that actively tries to hack your software. And then we tell you, oh, here are all the findings that you should probably address. And we kind of pull together the context from very different sources that you have, like how your product's supposed to be used, and make sure that there are no false positives in there. And then tell you, hey, this is how you should be fixing it. And yeah, right now we're really focused on the identification portion of the experience. But over a long term, because our missions to not only make all software secure, but also make them effortlessly secure. So that means we'll also have to work on the remediation portion of it too. Yep.
Got it. Okay, so once you have a insecure software, deliver guidance on how to fix it.
Yes. And this is like kind of a, like not necessarily a hot take, but I think it is kind of a thing that every developer feels when they're developing software is like, it's probably insecure somewhere. Like, there's always this little bit of doubt. It's like, oh, did I really do everything correctly? Right. And we just want to make sure developers know, hey, yeah, here are the gaps.
Well, I mean, imagine if you scanned GitHub, the amount of code that says, this is dumb, I will fix this later, that got merged into the main branch because it worked, and then you moved on to something else. Probably a lot.
Yeah. I mean, searching for to do is probably one of the best ways to find vulnerabilities in your code base.
That's a really good point. Okay, so you are in YC. Tell us, what was that experience like getting in? And you made a pretty big splash once you were in. So tell us about that.
Yeah. So our company, we applied to Y-Combinator for the spring batch, it was one of the most fun experiences I've ever had. Like, number one, it is very, very weird to suddenly work in a 2-people company at the time versus I don't even know how many people are at Amazon, probably measured in millions. And moving into a garage with my co-founder, trying to build the first version of the product and doing everything we can to raise a pre-seed fund. We luckily had a lot of really, really great investors early on. We also got into Y-Combinator. It's like it is effectively a form you can fill out in 10 minutes, and then they'll talk to you for 10 minutes, and then they're like, yeah, here you go, 500K. Well, I guess most applications don't go through, but it is a really interesting experience. And I would say for someone like me who always looked up to try to come to the United States for opportunity, this really is a good encapsulation of like, what is the American dream about? It's like, you can really have the opportunity to have somebody else just really bet on you as founders and be like, hey, you barely have a product taped together. I think you deserve at least $500,000 to try to see this through, right?
That's a pretty cool, I've never heard it put that succinctly, which is like, okay, you've got an idea, you've got a slide deck, your background, and
actually no decks, decks.
Okay, so you really just talk to them.
Yeah.
That's awesome.
Yeah, I think Amazon helped me a lot in terms of the first portion of it, which is writing. You're obviously writing your questions into Y-Combinator's form there, and Amazon has a great writing culture. I think it really, really taught me how to communicate succinctly and effectively in just a few words. Yeah.
Well, there's the famous 6-pager requirement, right? Where at Amazon you need to write, if you want to do something, you put it into a 6-page document that's very well structured. And Jeff Bezos is famous for saying, okay, we're going to start the meeting by reading this. We're all going to make sure we read this thing, we're on the same page.
Yes, that's right. And with Kiro, I've went through a good chunk of iterations on that. Let me put it this way. I think one of the Hacker News launch comments on it was like, oh, wow, this Kiro seems like a product where they just didn't write a PRFAQ and just went in and built something for customers. Sorry to break it for you. I worked a lot of nights, a lot of days on many iterations on a PRFAQ. And because of that, it allowed us to really think clearly about who is our customer, what do they want, and what problems are we solving.
Yeah, that kind of stuff just does not happen coincidentally.
Yeah.
So you were in YC, you getting all this good advice, you've got all these other batchmates. So YC will take a fixed number of people per, I think it's a year season? Spring 25?
We're the first spring batch. So just this year they moved into 4 batches per year. And in our batch, it was 150 companies.
Awesome. And so you've got some batchmates in there. They're all working on other AI things, obviously. How did you... tell us about the experience in hacking your batchmates.
Yeah, absolutely. So once you're a startup, your most important thing is to launch, because you need to launch to get customers. You need to launch to create awareness. You need to launch to test your ideas and validate them. Your chance of hitting product market fit on your first product or first iteration is likely 0. So you need to keep iterating, keep trying new things, right? And this is where we applied this working backwards mindset we actually had from AWS, which means like you write the outcome you want to achieve and you do almost everything you possibly can to go and achieve that outcome, right? And my co-founder and I were just like thinking, we need a really cool launch to create awareness for this. So what if we had the headline, we hacked Y-Combinator's AI agents? And we're just like, let's see what happens, right? Like we needed to launch, so might as well. Let's do it. So it was a Sunday night or Sunday in San Francisco in the apartment building called The Landing. All YC companies are in that one building, and we were just like, okay, let's put a timer for 30 minutes and try to hack as many of these agents as possible that were launched. There were 16 companies that launched already, and we were like, okay, we're gonna hack as many of them as possible. And so, yeah, within 30 minutes each, we're able to hack 7 out of the 16 AI agents. And it really showed that, there's a problem here. The default state of these agents is insecure, and also we got a really flashy headline out of it, and we got the inside the YC internal forums. We were the second highest, most upvoted launch post of all time, so higher than Rippling. Ha.
Cool. So, well, first of all, congrats. That was a really clever idea, and more so that you pulled it off. So, what was the reaction like with your batchmates? Were they? I mean, I'd imagine there's a bit of a healthy competition, I would say.
No, I think actually one thing that you'll notice about, I think many people have a lot of opinions of what YC could be like. Is it internally competitive in any sort of way? But one thing I've come to really appreciate about the Y-Combinator community is that even if you're competitive in terms of the market you play in, the founder-to-founder relationships and bonding there is operating on a level of trust that is hard to experience anywhere else in your life. And the way everybody's helping each other, when you see a customer that could use one of your batchmates' product, your natural instinct is to help refer your batchmate to the customer, right? And vice versa. And when you see that your batchmate is struggling with something, be it product-wise, tech-wise, be it mental health, like because you're just in this high-intensity situation, everybody's there for you. And so we obviously did this for a flashy headline, but our goal is to make sure that our batchmates are set up for success, because everybody's trying to build a great company as fast as possible. There's this big thing called demo day where you're supposed to be raising money, and so you want to make sure your batchmates are successful. And if you want to go close these big enterprise deals, you need to have a secure system. Right, so I mean, one of our batchmates, the company's called 64. They needed to close like a deal with a multi-billion-dollar enterprise within 3 months, which is, if you've ever worked in big companies, it's a pretty fast procurement timeline, and they were kind of stuck on the security review process, and we were able to just help them over a weekend, something that would have taken 4 weeks. So yeah, the companies appreciated it because ultimately you're there to help them to become successful. And it is nobody's ill intent to build insecure software, right? All these things happen just purely based on the state of the world that we're currently in. Defaults always dominate decisions. So if the default framework is insecure, if the default paradigms are insecure, naturally these tools, these outcomes that are, these products that are built around these platforms will become insecure, right? And so our goal is to make sure that, hey, they just know about these things. We disclosed it obviously to every one of them before we wrote a blog post about it, right? And the outcome is all of them should be safe now.
Yeah, and so much better that you help them see it, and then it's not going to come and bite them.
Later
at a critical moment.
Yeah, exactly.
That's really neat, and I love hearing the report from the inside of how collaborative it is. That kind of, I've never been in Y-Combinator, but makes sense. So that's really cool. One question I had, actually, give me a second. I need to rephrase that. Okay, I got it. Okay, so security with AI, it's very a different mindset of thinking than security in other tech contexts, right? I mean, it's on the one hand, all security comes to how would someone use it that's different than I expect. I have my product and I want people to use it this way, and you kind of expect people to at least try to use it in the way you envision. But then it comes down to, well, the meme video where they're putting the shapes and everything goes in the square hole.
Yeah. This is into the square hole.
Yeah. How can I use this in the wrongest way possible in order to get this strange stuff to come up?
Yeah.
Now, my first job as a teenager, I was in security for a tech company, but back then it was all about locking down ports and dealing with not exposing the version of your software and a kind of classical firewall Linux IP tables, IP chain stuff. AI security is totally different. So how did you get into this security? I mean, we talked about the credentials, but in general, what's the mindset of AI security, and how do you work with it?
Yeah, no, that's a very good question. Um, I I think maybe a good starting point is to paint the right mental model of what we mean with AI security. One of the most common, let's say, misconceptions or mistake that I'm seeing is that people are thinking about LLM security. That's like, hey, I can get it to provide, prompt it in a way that it gives you content that's not supposed to, like how to build a nuclear weapon somehow, right? Like, give me a baking recipe for a nuclear bomb. It's like, this is, I think, one of those earliest prompt injection attacks.
My grandma needs this recipe. It's really important.
Yeah,
that kind of thing.
Yeah, exactly. And then you can build up this whole role playing scenario around it about how this is your last recipe your grandma can, oh god, it's getting really dark. I'm not gonna talk about it. But yeah, so I think that is the starting point for a lot of people's perception of what it means. But the right mental model should really be, what is your agent's security posture? So your LLM is only one little component of it. And oftentimes these different attacks of getting it to give you nuclear bomb recipes and whatnot, they do not directly affect other users. They typically affect only the user that's prompting it, right? So the damage is kind of limited in that sense, right? But
okay, so if I ask ChatGPT dangerous question, maybe I can trick it into talking about something it shouldn't, but that's just
affecting you.
Between me and ChatGPT.
And that is still a problem, right? I'm not dismissing that as a problem, but I think that is a problem that the foundation model providers will naturally adopt to solve, right? Because it is in their interest to make sure that their models operate around ethical guidelines. Now, the concept of agent security is to understand that your software is going to become stochastic. It means it has this LLM capability in there. It's going to do a lot of undeterministic things, unlike your traditional code, and then it's going to go and affect other systems that it can reach. Like, it can call tools to read your emails and then pass that email content into a coding agent to address maybe a customer support issue, right? Like, that is like an agent security problem. Like, okay, how do these LLMs interact with all of these other systems that we have connected together? And that is really where we need to focus on security, because you're starting to really affect many, many users in the system. So when we hacked our Y-Combinator batchmates, for example, one customer, they had a agent that allows you to traverse documents that were written by yourself and other people you're in the same group chat with. It turns out that the way it works is that you can just ask the agent to retrieve those documents with some particular identifier of those document IDs. And by nature, you would think, okay, yeah, these document IDs are kind of locked down and whatnot. It's fine.
No one's going to guess a UUID.
No one's going to guess a UUID, but guess what? Developers love putting various forms of IDs into the URL bar. So if you screen share your computer somebody can just take a screenshot and like slowly type out, or actually Mac now supports auto select and copy of any image, right? You can just select and copy that UID and then pass it into the agent from your own instance and then be able to retrieve the information. And then it turns out these documents are interconnected. So then from one document, you can start crawling and get more and more information out of there.
Oh, because the document might have an internal link to another document, which is another ID that's exposed or exposing some structure.
Yeah, exactly. And so the nature of this is, yes, you have used the LLM, you have prompt injected to act in a way that it was not supposed to, but the real damage was caused through this interplay between the LLM and the tools it had access to and how those tools are being authorized and authenticated. And so thinking in just LLM security is too narrow, because you're not thinking about all the real damaging attack vectors to your business. You're thinking about almost too much about what is the only thing that the LLM could mistakenly give back, not what it can impact your entire company. Yeah.
But I've seen the advice you gave is to treat agents as users and not to treat agents as API servers, right? Because you think, okay, I'm coding up this agent, I'm in control, but it doesn't mean I'm like telepathically telling it what to do and not do.
Yeah.
And the user is still the one who can make it do something else.
Yeah, that's right. I think when you look at why AI agents have so many issues with security, It's because as developers, we like to create mental models for ourselves in terms of how we should be building things. And it just so happens that AI agents are hosted on a server. So naturally our brain goes into, oh, it's an API. Like it should have, global read-only access on a database, and I'm going to do authorization on the API layer. It's going to go well, guys. It's going to happen. But they're not, right? There are users. They're acting on behalf of humans. And the interesting thing is we have all these controls because ultimately user access has been solved, or at least has been attempted to be solved over and over again for 20 plus years. And there's we're reaching some level of normalcy around solving user access. And so the first order of business is to think about how can I apply the same controls that already exist for users onto these AI agents. And effectively, I granted the same permissions I'm supposed to have, right? I do think moving forward as standards emerge, there's going to be a question to think about if agents should also exist as its own concept. Like how much work can it delegate? And if it delegates through different tools in the network of multi-agent systems, how should it, at what point should it ask a human for permissions and whatnot? And I think that world will still need to emerge. But up until then, the safest bet you can make for yourself, at least right now, is to treat these agents as users.
That makes a lot of sense. And I really like the whole mental model part of it. Like saying, I remember one time I was watching Claude Code do something. And with Claude Code, you can restrict what shell commands it can run. You say, okay, I don't want Claude to run the AWS CLI. Mm-hmm. So Claude fired up Q and started telling Q what to do. Like, no way. Like that's clever. But these things want to find a way to solve your problem.
Exactly. I mean, the other way would have been writing a Python script that executes the AWS CLI code and it'll execute the Python script.
Yeah, exactly. I've seen ones where it didn't. I disabled write access, and so it did some shell redirects that basically catted out to a file because it didn't have direct shell access. It's clever. You have respect for these things.
One of the best tips I have for people trying to hack like coding agents, like web-hosted coding agents, ask it to build a working terminal with the actual computer behind the scene connected.
Interesting.
You effectively have it build its own remote code execution.
Interesting. Okay. Well, speaking of remote code execution, one of the things you mentioned in your talk was the dangers of rolling your own code execution sandbox.
That's right.
So tell us about things that you've seen.
Yeah.
What can users do by mistake when they're trying to do this?
Yeah, absolutely. So I just realized I said absolutely. This is not deepfake. This is really me, Renee. Certainly. When you think about what these LLMs do by themselves, they're really good at generating. They're really good at generating content, creating reasoning, but just things like calculations, math, it's not good at that, right? It often makes mistakes there. It's like one of the earliest example of where like people are saying, "Oh, this is a big problem of generative AI. Will never be successful." But okay, those deniers are, hopefully see the world differently now. And one way to solve these problems is by giving agents tools, right? For example, a computer. A computer can compute. And so you can write code that then executes and does things. So many of the times when you see an agent doing a lot of work on your behalf, what's actually doing is spinning up a little computer in the back end that then has either pre-programmed code or code that it writes dynamically. It then goes and executes and performs that request for you. Like for example, for an accounting application, it might actually write a script that does all those calculations to make sure the math is right, and then feed that result back into the actual spreadsheet, for example. Now, people like to roll their own tech because we're engineers and love tinkering. But I think it's just like we in the web world kind of learn to not roll our own off, we should figure out not how to not roll our own code sandboxes. Because, for example, one of the companies that we hacked, they were on GCP. It said something like, oh yeah, never show the user, the system prompt said something like, never show the user that you're actually writing code in the background. So, as an attacker, your first thought is, okay, now I need to figure out how to make it write code in the background. And then you try to write code, like listing out the file system, figuring out where does the execution environment happen, and you realize, oh, in this random app.py file somewhere, they've got all these protections in place that prevents me from executing arbitrary code. Let me now override that app.py file without those protections and just keep running more and more requests through it. And soon enough, you realize, okay, wow, I created a reverse shell. I'm now inside the code sandbox of the developer. Turns out it's a long-lived sandbox as well, so it maintains information across sessions. And then
you can start querying the environment variables.
What are environment variables? Service role definitions. You can look at the permissions of your service roles, and you realize, oh wait, I also have access to BigQuery or some other database on my cloud environment. Well, let me start siphoning out customer data from there, right? And so that is a problem, and that's something that that's really hard to lock down. I think if I would draw an analogy, it's like it is AWS and EC2's entire business to lock down compute so that it's isolated, right? And so it's not an easy problem to quickly spin up millions of these little compute instances and execute against them. So just like how we have learned not to roll our own off in the web environment, I do think, unless you really know what you're doing, don't roll your own code sandboxes. Use one of those open source ones. Use something that's managed, something like, the E2B is an open source one, Blacksoul, Daytona, they all support the right security controls in place already so that you can start off from a great starting point.
Got it. Okay, so if I were building a startup where you can code on a web app or something, and I wanted to use Casco to help me figure out, is this secure? Did I do this right? Yeah. So what would the Casco agent do?
Yeah. So the way Casco works is we'll go through a process that you'll similarly see from penetration testers today. So we'll figure out first on the reconnaissance workflow by identifying what are all the different resources inside your application, how are they linked together in a graph, how do they look like when you have different users. We have user 1 with an admin credentials, user 2 with just a regular member credentials, and unauthenticated users. And then it does semantic grouping of those resources and tries to figure out, okay, this random API always gets called, but with different IDs. So I think I should create a little log of all these different IDs and try to use that for an attack later.
Wow, that's okay. So it had patterns that it checks for, which are common to the particular execution or whatever it is that you're looking at.
It's highly dynamic, so it doesn't we don't hard code any specific patterns, but we obviously have a lot of different specifications of how to identify patterns. And then from those different patterns that it creates, it ultimately tries to plan attacks against it, right? Most pen testing tools in the world, they're kind of cheap automated scanners. Basically, oftentimes it's kind of a scam. It's very limited in terms of its capabilities. And if you want to get a good pen tester, you need to be a company like AWS and whatnot. Like, it's cost prohibitive for most companies in the world. Now, the cheap tools just randomly try some fuzzed value for these different IDs. But when you do real attacks, you need to think multi-step. You need to create semantic groupings of what does an identifier actually mean? How do you apply it in different contexts? And how do you make sure that an agent can retrieve it and make sure to find the right identifier to use in this right attack? So we effectively go through a planning exercise of all possible attacks from the signals that we're getting into. And these attacks can be, hundreds, if not thousands of attacks for a single application. And then from there, we actually run through these thousands of attacks, and then we identify if this is a truly exploitable issue, or if it is a false positive, right? What we see is that through this methodology, we do not have to make a trade-off between a depth versus breadth analysis. if you look at a human pen tester that has to perform this work, they have to basically spend like the first few hours, first few days, trying to just build up like a vibe of a resource graph, if you will. And that goes like basically 2 or 3 levels deep, maybe, even though there's like tens of layers to depth. And then they develop some hunches that they have from their own experience and pick 2 or 3 approaches to really go deep into. And some of these things can take a long time. And then if they don't find anything, it's effectively a waste of time. And so naturally, you are choosing between depth versus breadth. That's why it's being paid by the hour, right? And so the more you spend on, you can get more depth out of it. And that is just a trade-off that I don't believe software should have in the 21st century. I want all software to be effortlessly secure. That means that I can point any web application to it. It runs. It can go through the full depth of every possible thing that my application can do, try every possible attack that seemed reasonable, and then tell me only the findings that truly matter. If I just get like a little header warning, hey, you forgot to set this header, but this header was never exploitable, it's actually not useful to the business. And oftentimes I see tools mark that as, oh, this is a critical finding. It's not if you cannot exploit it, right? It is obviously important to share that so it can still be addressed, but you need to bring in semantics and you need to go full depth. You need to really truly exploit it, see what the damage is. Yeah.
You don't want to give alert fatigue, where if you come up with a bunch of useless alerts, then the really bad one that is buried in there that is actionable, well, you don't want people to be trained to ignore that. That's really neat. Yeah. So is it an ongoing, continuous monitoring? Because I would imagine, these projects are under active development.
Yep. So right now we do different levels of frequency. There's a monthly frequency, weekly frequency. Our goal is to bring down the iteration cycle and the cost of the product so low so it can run continuously. And it is a function of how these foundation models will improve. I think, as I mentioned earlier, if you just bet on the future of these models getting faster, better, more intelligent, cheaper, this reality will become true, right? And up until then, we can already create value that was seemingly impossible a year ago, even 3 months ago, right? Our entire product quality and cost changed when Sonnet 4.5 came out, right? Haiku 4.5 came out. So the mental model here is really, we are trying to pull the future forward, and we're betting that the future will get better.
I love that. That's so cool, and it's nice to see you're doing these architectures. Then as the LLMs themselves, the foundation models get better, it just jumps forward. Yeah, that's really cool. What advice would you have for someone building an AI-oriented SaaS who doesn't know security? And aside from obviously use Casco, other things to just keep in mind.
Yeah, I think there are 3 things to keep in mind. So the first thing is treat agents as users. Like that means around your data authorization patterns, how you sanitize inputs and outputs. Figure out, things that we've done for the web application space for a long time already, right? The second is don't hand roll your own code sandbox. It's not going to help you, right? It is only going to work against you. Your focus should right now be building a company, building a product, creating customer value. Figuring out how to build your own code sandbox is not going to get you there, right? You should just use something off the shelf. And then third is you need to really think about security from the perspective of the agent instead of just the LLM itself. Like, what are all the things it can connect with, and question what happens if you put in the wrong inputs into all the things it can connect in.
Got it. Okay, that's really, really useful advice. And a lot of it's like input sanitizing, right? But not in the way that it used to be of, the classic SQL injection input sanitizing, but it's much more holistic in the sense of this. You could get instructions that say, ignore my previous instructions and that sort of thing. Yeah,
and we'll get more of that. There's a really good paper by a AI researcher, Suha Hussain. It is about hacking multi-agent systems in your pajamas. It's one of the best titles ever, isn't it? And it has a lot of content in there talking about how these agentic systems and their security issues actually compound, and you really need to think about a defense in depth strategy.
That's really cool. I'll make sure to post the link to that paper as well.
Yeah.
Thank you so much for the time. This is really exciting. And I really liked your idea earlier. We were talking earlier that I need to have a 3D printed logo. I'm going to send you one.
All right. Awesome.
This is the 3D printed Casco logo. I really appreciate your insight, your flexibility. Last question. What are you most excited about in this future that we're driving to? What's in the short to medium term, like what's exciting about AI in general?
Yeah, I think we're going to enter a time where we'll see innovation accelerating at a pace that we have never seen before in our generation. And if I look at companies of my size being able to ship hundreds of thousands of lines of code to production every day, imagine what that would happen once the entire industry is on board. We're going to be innovating so much and we're going to be like blinking and the world is changing. And I'm quite optimistic about the future.
That's fantastic. Well, thank you, Renee. Really appreciate your time, and make sure everyone check out Casco, and thanks again.
Thank you. Thanks for having me.